as we begin our unit on biology, one of the first things that we're going to be doing is using microscopes to be looking at some different materials and different organisms. So we're going to have a lesson on microscopes right now, so make sure that you are taking visual notes because you'll need to be able to refer back to these in class as we're working with the instruments. So the word microscope, we can break it down into two parts. The first part, micro, means very small, and scope means to look at. So we're looking at things that are very small. Microscopes use lenses, which have been in existence for thousands of years. Typically, the first lenses were made out of glass. Now they're made out of, you can get them out of different plastics and acrylics. We see them, they can be hard, like glasses or a telescope lens or a microscope lens. They can also be soft and flexible, like a contact lens. The first crude microscopes, so these are, we're using the word crude as in rough or not very accurate. Microscopes were created over 400 years ago while people were experimenting with eyeglasses and telescopes. And we have the creator of microscopes, Anton van Leeuwenhoek. He lived in Holland from 1632 to 1723. And he is considered the father of microscopy. And he was very interested in lenses and creating the first microscopes. And so that's what he was working on. Here are some pictures of some of his inventions. And that is a picture of him. And he is famous. He made numerous first observations and descriptions of microscopic things, including many of which were living things. So he was one of the first people to, not only work with microscopes, create microscopes, but also to use them and record data from them. So observations and make descriptions, drawings, things like that. We also have Robert Hooke. He was living in England about the same time. And he was famous also for making observations of microscopic life. This is one of his works where he published his observations. And in 1665, he coined the term cell, which he used to describe the cells of plants. Specifically, he was looking at cork, which he felt looked like tiny rooms. And specifically, he was thinking of monks and monasteries and their very simple lives, and they had just, simple little rooms, and it was kind of like in a hallway all in a line, and that's what he was thinking of when he looked at the cork. Most microscopes use light to pass through a sample or to be reflected off of it, and there are many different styles. And this is the one that we use in class, and the light shines from right here. So let's talk about the parts of the microscope. We have the eyepiece lens, which has a 10 magnification. And we have objective lenses. There are 3 different ones. We have a 4 magnification, a 10 magnification, and a 40 magnification. And we'll talk in a minute about what that means. We have the stage. This is where we place our specimen, typically on a slide with a slide cover. As I said before, this is our light source down here. So this whole thing gets plugged into an outlet. You turn it on, there's the on switch, the light shines up through a hole in the stage. And your specimen is over top of that hole. This little dial right here, I'm not sure if you can really see it, that's called the diaphragm. You can spin that, and it either makes the opening wider or more narrow, and it lets more or less light shine through the stage onto the specimen. This is the base of your microscope. It's what sits on the table. You have your coarse focus, which is this larger wheel here, which moves up and down. It moves the stage up and down so that you can bring your object, your specimen, into focus. And here we have the fine focus. So that's really allowing you, because your specimen is three-dimensional, no matter how tiny it is, to focus somewhere in your specimen. So you might need to, you'll adjust that as needed as well. So we're going to talk about the field of view, or FOV. And the field of view is everything in the circular area that you can see through a microscope. So this is your field of view. That black line, this is a pointer. It's on the stage. It's on the hole on the stage. And so if you're looking at a specific part of a specimen and you want to call someone else's attention to it, you can slide it so that the pointer is pointing right at it and someone else could see it. There's also what's called the focal plane, and that's the area of a sample that you see clearly. So, for example, take a minute, stretch out your hand, like hold your hand up, and focus on one finger. And you'll notice that the background behind your fingers looks blurry. And that's because your focal plane is on the finger, even though you still see the background. And you can do the opposite, so focus on an object behind your finger, and you'll notice that all of a sudden your finger appears blurry because now you've switched your focal plane to look at that other object. Let's talk about magnification. So the X written next to a number, so for example 10x, refers to how many times bigger the object appears to be compared to its original size. So the microscopes that we have, the eyepiece lens, the eyepiece magnification is 10x. So the object appears to be 10 times larger than it actually is. So, for example, if we have an object that's 1 millimeter long, it will appear to be 10 millimeters long when you're viewing it through the eyepiece, if you're using just the eyepiece. So again, this eyepiece has a 20x magnification. This is a 4, so the object would appear 4 times larger. 10x, so it would appear 10 times larger. And 40x, so 40 times larger. And again, these are your 3 objective lens magnifications. So when we're talking about magnification, we also need to talk about the total magnification. That's really what we're concerned with. And that's the magnification that occurs by using 2 or more lenses. So we're using actually 2 lenses here. We've got our eyepiece lens, which has a magnification, and our objective lens, which also has a magnification. So if our eyepiece lens is always going to be 10 magnification, because that's the kind of microscope that we have. So our eyepiece lens has a 10 magnification, our objective lens has a 4. What you do is multiply them. So multiply your eyepiece magnification by your objective lens magnification. So 10 times 4 gives us a total magnification of 40. So that means that when we're using our 4x lens, our object will appear 40 times larger than it actually is, because we've also got that eyepiece lens magnification. So we have our eyepiece here has 10. This time we're using our 10x objective lens. 10 times 10 gives us a total magnification of 100 times. So the object appears 100 times larger than it actually is. Now we have our eyepiece lens magnification of 10. This time our objective lens is has a 40 magnification. 10 times 40 gives us a total magnification of 400. So a couple things to remember when we're using microscopes. Microscopes are expensive, so please handle them with care. You're always going to use 2 hands to carry it. I'll show you exactly how to carry it in class. You want to make sure that you're walking, that the cord is wrapped securely around the base of the microscope so that nobody trips on it. Guys, this is why it's really important that we don't have backpacks or anything in class, because we're going to be carrying some expensive equipment. We want to make sure that things don't get dropped. And then when you're looking through the microscope, you're always going to start with the lowest magnification first, which for us is going to be our 4x, and that's the shortest objective lens. And so then, even if you want to be looking at something under the 40x objective lens, you're always going to start with the 4 and work your way up. That makes it easiest for you to find your object and focus it. So make sure that you go to Edmodo and take the Edmodo quiz.